1.5, Energy and Momentum Preview. So we've been talking about forces and velocities. These are just a couple more ways to think about interactions. These two other ways are energy and momentum. How do we use energy and momentum to predict what happens with simple interactions? So we've got our objectives are being able to define the types of energy, being able to articulate and apply the law of conservation of energy, being able to define momentum, being able to articulate and apply the law of conservation of momentum. Here's your reading pages, if that's for you. If not, lots of words. Here we go. System, a collection of objects that interact with each other in some interesting way. Surroundings, or everything else that is not part of the system. So sometimes the word is used. Sometimes the word environment is used. We've got energy. Energy is a scalar quantity that an object possesses that must be transferred during an interaction. Remember, scalar just means that there is no direction associated with it. There is one kind of energy that will seem like it has a direction, where it's negative, but we'll talk more about that. But for right now, you're not going to be dealing with a negative energy. Later in the year. E is the symbol. So for any type of energy, and we'll use subscripts to differentiate among them. The units for energy are measured in joules with a capital J, joules like pools. Kinetic energy is one form. The energy possessed by a moving object, right? Kinetic, what we're studying right now is kinematics, the study of motion, the Xbox Kinect. All of this means moving. The symbol that we use for kinetic energy is K. Units, again, are joules. Gravitational potential energy. That's the energy an object possesses if it has a height. So when you raise an object above the ground, that means you are having gravitational potential energy within that system. Symbol, capital U sub G. Units are joules. Elastic or spring potential energy. That's the energy possessed by a spring or a rubber band, as it's compressed or stretched from its natural length. And for that, because it's potential, we use the letter U, U sub S for spring potential. And guess what the units are? Thermal energy, the energy possessed by an object that has a temperature, E sub TH. Thermal energy measured in joules. Chemical energy, the energy possessed by an object that is made up of chemicals bonded by chemical bonds. Symbol, capital U sub C. Units, joules. Sound energy, energy carried by a sound wave, E sub sound, measured in joules. Light energy, energy carried by a light, E sub light, joules. We won't deal with these in this course, but they're there. Momentum, a vector quantity possessed by a moving object. Symbol P, or which is a lowercase p, not a capital P. That would be something different. So momentum is a vector, so we have direction. The units for this are kilogram meters per second. kg times meter per second, or you can just say a Newton second. Newton times a second. All right, that was our vocabulary.